Hello, hello. Welcome to 9.1. Go ahead and grab your math notebook if you haven't already. We're going to put in some notes. Make sure in your table of contents that you add a different section for Chapter 9. And then the title for this is going to be line plots. Don't forget your page number. And as soon as you have that done, then we'll go ahead and get started. So pause the video if you need to, but I'm going to jump in. Okay, line plots. I'm sure you guys are familiar with. I believe that you've seen these before in the past in many different places. And basically, they're just one way to show data. There we go. Okay, so if I had a data set that looked like this, if I had a triangle and a triangle and a circle and a square and a square and a square, some of my squares are not so square. I'm looking off my notes from earlier. Okay, if I had a data set that looked like that, it would be really easy to go ahead and put it in a line plot that would look like this, where we would put each of the shapes from above, and then for each one from up in the data set, we'd put an X down here. So I see one triangle, and here's another triangle, and here's a circle, and here's a, oops. I put a circle instead of an X. Oh no, X. And then we've got a square, and we've got a square, and we've got a square, and on and on. You could go ahead and do the whole thing. That's probably as much as experience as you've had with line plots, and that's great. That's a really fabulous place to start. But there's more that we can do with line plots. Okay, so one thing that we have been talking about so far this year is fractions, and we can use line plots with fractions too. Can be used with fractions. I don't know why this is going crazy on me. Sorry if that's hard to read. Can be used with fractions. And then once we have our line plot built, we are able to use that line plot to collect other information and figure out more things about the data that were provided. So a lot of times you'll see this data come in the form of a question, and then you build the line plot from there, and then you look for other information. So if we were having a class party and you guys all just had your water bottles, and I wanted to know how many cups of water do the 5th graders drink based on the data. I'm going to kind of go off the page here. Okay, so I'm just going to come up with a little cup amount for each of you. Let's say that Ollie drank 1/3 of a cup, and Bailey had 1/3 of a cup, and Boyd had 1/4 of a cup, and Caleb had 2/5. And Cheyenne had 1/4, and Isaac had 1/3, and Murtis had 1/4. I guess I've been forgetting to write my C's, but you guys know. And Rylan had, stop it, 2/5, and then Taya had 2/5. So there's one for each of you. And let's go ahead And now put this information into our table, or into our line plot. So if I want to know how many 1/3 cups, how many 1/4 cups, and how many 2/5 cups there are. I'm going to do the same thing you saw me do with the shapes. Here's a 1/3, so I put an X. Here's a 1/3. Here's a 1/4. And it's easiest just to go in order, I think. That way none of them get skipped. Here's a 2/5, a 1/4, a 1/3, a 1/4, and 2 2/5 in a row. Okay, so you can look at that and say, well, we all, between the 9 of us, 3 each had these different amounts to drink. Well, that's great. But what other information can we gather from this line plot based on the data that we had up here? Okay, I'm going to turn the page, but we'll be kind of toggling back and forth. So, this is something that you'll be asked to do on your homework. To find the total amount of water, or no, of cups, sorry. To find the total amount of cups, multiply each fraction by the number of students who had that much, then add them together. Maybe. Okay, so I know that I had the amounts of 1/3, 1/4, and 2/5. So, to find the total amount of cups, multiply each fraction, each of these, by the number of students who had that much. So that's the first thing we have to do. So now we go back and look at our data. Maybe. There we go. So there were 3 that had 1/3, 3 that had 1/4, and 3 that had 2/5. So I'm going to come over here, times 3, times 3, times 3. And we have seen this before, doing a little review, going back to multiplying fractions. What do we do with these whole numbers over here before I can multiply? I'll give you a little hint in a different color. Gotta put them on top of 1. And then you just multiply and simplify. So 1 times 3 is 3, and 3 times 1 is 3. And we've seen this before too. When we have the same number on top and bottom, that's equal to something else. Write down what you think it is, and then I'll put what I think it is. Did you put a whole? Any number over itself is a whole. That could be true for 12 over 12. It could be true for 100 over 100. Any number on top of itself is one whole. Okay, let's keep going. 1 times 3 is 3. 4 times 1 is 4, and that's already in simplest form. Nothing goes into 3 and 4 together. Last one, 2 times 3 is 6. 5 times 1 is 5. Uh-oh. What do we got going on down here now? An improper fraction. We can't have the top number be bigger than the bottom number. That numerator has to be smaller than the denominator like it is up here. So to simplify this, go ahead and do that if you remember how. If not, keep watching. To simplify, you have to find out how many times the bottom number goes into the top. So 5 can only go into 6 one time because 2 times 5 is 10, and that's too big. So 5 goes into 6 one time. 6 minus 5 is 1, and then we keep our denominator. So this one is 1 1/5. And then we just add them together. So this goes way back. Now we have to go back to adding and subtracting with fractions. I have 1 whole plus 3/4, maybe. 3/4 plus 1 1/5. Okay, before I can add these, I have to do something with these two fractions. Remember what that is? We have to find a common denominator. So I'm going to scooch over my 1 whole. We keep that. And then I'm going to scooch over these numbers, but they're going to change a little bit. So 3/4 is going to become something different, and that 1/5 is going to become something different. But my 1 will stay the same. Oh my. My 1 will stay the same, so I'm going to put that back. Okay, for these fractions, what is a common denominator for the 4 and the 5? What do both of those numbers go into? Give you a second to think and write it down when you know what it is. They both go into 20. And then I just have to simplify, or not simplify, but find out the numerator. So 4 times 5 is 20. Whatever you do to the bottom, do to the top. 3 times 5 is 15. 5 times 4 is 20. Whatever you do to the bottom, do to the top. 4 times 1 is 4. Now I can add. 15 plus 4 is 19. Remember, we always add fractions first. And then we have 2 wholes. Check for simplest form. Can anything go into 19 and 20 at the same time? Not that I can think of. So that would mean that this is how many cups of water you guys drank at our party, if we had a party. Okay, I'm going to stop the video. No, I'm not. Nope, ignore that. I'm going to keep going. I was looking at my timer. I only have 15 minutes and we're at 13. So we're going to just do this next part really quick. Okay, on 9.1. Oops, let's see. Nope, I lied. I am going to stop the video, and then I'm going to come back and show you how to do this stuff on the book. Okay, I'll see you in a little bit.